As you can see, I've already shown all my working out here, so I'll just talk you through it. Part A, we need to prove this trigonometric identity. So I've started with the left-hand side because there's quite a lot for me to do here. First thing I've done is I've rewritten this cosec squared as 1 over sine squared. And we've got 4 lots of that. Then I've taken this sec squared and rewritten that as 1 over cos squared. My next step is this sine squared 2 theta here. Now I know that having the squared on the inside here, that's just the equivalent of me saying sine 2 theta squared. They are exactly the same thing. So what I've done then is I've taken that sine 2 theta and I've written that as 2 sine theta cos theta with the squared there. The next step, I've actually squared that out. So I've done the 2 squared, which has given me the 4. Then I've done the sine theta squared. And then I've done the cos theta squared. Then I've noticed the 4's here are going to cancel out. So I'll divide top and bottom by 4. So I'll just be left with the 1 on the top. And then I've got this sine squared, cos squared on the denominator. And previously I just had a cos squared on the denominator. So in order for me to subtract these 2 fractions, I need a common denominator. So that is why I've multiplied top and bottom here by sine squared, so that these denominators match up. And I can then combine those 2 fractions together as a single fraction, with 1 minus sine squared on the numerator. This 1 minus sine squared, I know that's the same thing as cos squared, which I then notice is going to cancel out with this cos squared, and leave me with just 1 over sine squared, which we know is the same thing as cosec squared, which was what we needed to show. So that is part A done. Part B says to hence show that if this, then either sine theta is a half or sine theta is minus 1/4. So it doesn't actually ask us to solve this whole equation, it just asks us to get to this point. So I'm looking at this equation, and to begin with I can't see easily how this relates to the identity we had in part A. There's bits of it that I recognise. I recognise the cos squared here and the 4, but I can't see any sec squared there. So to begin with, nothing matches up perfectly. So what I've decided to do is just to expand these brackets to begin with. So I've done the 4 times the cosec squared 2 theta, and I've done the 4 times the minus 2. Then I thought, well, if I subtract this sec squared from both sides, and I'll add the 8 over there, then that gets me this 4 cosec squared 2 theta minus sec squared theta. And that matches up perfectly with what we did in part A. So that allows me to replace all of that with the cosec squared, which is what I've done here. Now I've got an equation that's only in terms of cosec. So I've added the 2 cosec theta, I've subtracted the 8 to make it equal to 0. I've then factorised that quadratic. The 4 and the minus 2 give me the minus 8, and the 4 plus the minus 2 gives me the plus 2. So that allows me to say that cosec theta is either minus 4 or cosec theta is equal to 2. We know cosec is the reciprocal of sine, so I've just done the reciprocal here. The reciprocal of minus 4 is minus 1/4. The reciprocal of 2 is a half. And these are the 2 things we needed to show.